All right, we're all starting to rely on these amazing AI assistants, right? But what happens when someone figures out how to turn those helpful tools into a weapon against you? Well, that's exactly what we're diving into today. We're going to look at this wild new AI vulnerability called prompt injection and see how it connects back to some classic, old-school cyber attacks to create a brand new, very sneaky threat.
I mean, really think about that for a second. You ask your AI to do something simple, like summarize a document for you. But what you don't know is that there are secret instructions buried inside that document. And your AI, it follows those instructions, not yours. Suddenly, it starts shipping your private data off to some attacker. And this isn't some far-off sci-fi movie plot. No, this is happening right now. It's a very real threat, and it's called prompt injection.
Okay, so here's our game plan. We're going to start with the AI's core weakness, its blind spot. Then we'll see how hackers are exploiting it. We'll trace the whole attack from prompt to payload, talk about hijacking your digital identity, and wrap up with how to build what's called a zero-trust AI.
All right, let's get into it. Section 1, the AI's cognitive blind spot. Now, to really get a handle on this, you got to understand that the game has totally changed. We're not talking about predictable old-fashioned software bugs anymore. We've entered this much fuzzier, probabilistic world.
And this shift is a really big deal. See, with traditional software, bugs are deterministic. It's like a math problem. If you find a flaw in the logic, you can exploit it the same way every single time. It's predictable. But AI? That's probabilistic. It's not following a strict set of rules. It's making educated guesses. And that means its failures are completely unpredictable. It might work perfectly 100 times and then fail in a really weird way on the 101st. And how do you defend against something you can't predict?
This leads us right to the heart of the problem, prompt injection. And yet, it's so serious it's literally the #1 threat on the OWASP top 10 for large language models. The key thing to get here is that you're not breaking the code. You're tricking the AI's mind. You see, an AI's whole job is to follow instructions. So it has a really, really hard time telling the difference between the original rules the developer gave it and a sneaky, malicious instruction someone hid in the data it's looking at. That line between safe data and dangerous command, it just vanishes.
So the big question is, how does an attacker actually sneak these instructions in? Well, this is where it gets really clever and really dangerous. The attack vector is basically invisible.
Now, you've probably seen people jailbreaking chatbots online, right? That's what we call direct injection. It's you talking directly to the AI, trying to trick it. But the real danger, the one that scales, is indirect injection. This is totally different. Here, an attacker just poisons some data. They hide a malicious prompt on a web page or in an email, and then they just wait. The AI stumbles upon it, processes it, and becomes a victim. This turns a small one-on-one attack into a massive one-to-many problem.
Yeah, let that sink in for a second. With indirect injection, literally the entire internet becomes a potential weapon. Every single piece of data your AI might interact with, a website it's summarizing, an email in your inbox, code it's analyzing, all of it is now a potential Trojan horse. The attack surface isn't just one application anymore. It's everything.
And believe me, crafting these isn't random. It's a whole science. It follows this thing called the CFS model. First, context. The malicious instruction has to fit in with what the AI is expecting to do. Second, format. It's got to be disguised, blended in with the normal data, like maybe hidden in some code comments. And finally, salience. This is the key. You use urgent, attention-grabbing words like critical update or system override to basically hijack the AI's focus and make it obey your command above all others.
And if you're thinking this is all just theoretical, think again. These attacks are happening in the real world. We've seen a coding AI get tricked into making a simple diagram that also happened to steal and send off the project's API keys. We've seen an AI-powered web browser read a web page with hidden text, and that text made the AI go into the user's email and start exfiltrating data. This stuff is real, it's happening now, and the consequences are huge.
Okay, so the malicious prompt is in. But how does a simple little text command turn into a full-blown cyber attack? This is where things get really interesting, because this is the point where the brand new world of AI vulnerabilities hooks right into the classic web attacks we've been dealing with for years.
And the perfect analogy for this is the confused deputy problem. It's a classic idea in computer security. Your application trusts the AI, right? It's given special permissions, it's a privileged part of the system. The attacker can't attack your system directly, so instead, they trick this trusted insider, the AI, into using its own legitimate powers for a malicious purpose. The AI becomes the attacker's pawn.
So let's walk through a perfect step-by-step example. Step 1. An attacker crafts a PDF resume and hides a malicious prompt inside it. Step 2. An HR manager, trying to save time, asks their AI tool to summarize that resume. Step 3. The AI, our confused deputy, reads the hidden prompt and generates a summary that now includes a malicious script. Step 4. The HR application displays that summary, and boom, the script executes right in the manager's web browser. And the final step, compromise. That script steals the manager's session cookie. And just like that, the attacker has complete access to their account.
And what's so scary about this is that the attack is often completely invisible to the human eye. The attacker can use super simple tricks, like putting white text on a white background. So when the HR manager looks at the resume, it looks perfectly normal. But the AI? It doesn't see colors. It reads the raw text, so it sees the malicious command plain as day. This means even if you have a human reviewing things, they'll miss it completely.
Which brings us to the end game. What is the ultimate goal of this whole convoluted attack? It's all about hijacking the user's digital identity.
So that malicious script has one job, and one job only: steal the user's session cookie. Think of that cookie as a temporary key to your account. After you log in, your browser holds onto it to prove you are who you say you are. If an attacker gets their hands on that key, they don't even need your password anymore. They can just show the key to the website and they're in. They have full access. And for anyone who's been in security for a while, this is a classic cross-site scripting attack, or XSS, just delivered in a brand new way.
This is why where you store that session key is absolutely critical. If you're a developer and you're storing it in local storage or just a standard browser cookie, well, you're making it way too easy. Any bit of JavaScript, including the attacker's payload, can just grab it. But there's a simple fix: the HTTP-only cookie. Setting this one little flag tells the browser, hey, do not let any JavaScript touch this cookie, ever. And with that one change, the attacker's main goal is completely blocked. The whole attack just falls apart.
Okay, so we've seen the problem, and yeah, it's pretty complex and kind of scary. So what do we do about it? How do we actually defend against this? It really requires a whole new way of thinking, a new philosophy for building our systems, a zero-trust approach to AI.
Look, there's no single silver bullet here. A real defense has to be layered. Think of it as a three-part strategy. First, you defend the input, scrutinize everything going into the AI. Second, you defend the output, sanitize everything coming out of the AI. And third, you harden the user's session, which is your last line of defense, making sure that even if the other layers fail, the damage is contained.
Let's talk about that first layer, input defense. This is all about architecture. A huge one is to stop mixing your system instructions and user data in the same place. Keep them separate. And this is so important. Apply the principle of least privilege. Your AI should not have God mode access to your entire system. Give it only the permissions it absolutely needs to do its job, nothing more. And for really high-stakes stuff, make sure a human being has to give the final okay. Okay, layer 2, output defense. The mindset here is incredibly simple. Never, ever trust the AI's output. You have to assume that every single thing it generates could be malicious. In practice, this means sanitizing any HTML it produces using a solid library like DOM Purify. It means using a strong content security policy, or CSP, to lock down what scripts are allowed to run. And if you can, the gold standard is to render all AI-generated content inside a sandboxed iframe, completely cutting it off from the rest of your app. And that brings us to our third layer, session hardening. And I'm going to say it again because it is that important. Your single most effective defense against this entire class of attack is setting your session cookies to HTTP only. It's simple. It makes the cookie invisible to JavaScript. If the script can't see the cookie, it can't steal it. Game over for the attacker's main objective.
So when you put it all together, it really points to a huge shift in how we need to think about security. We have to stop viewing our AI models as just another trusted piece of our system. We have to start treating them like a potential insider threat, a component that might be compromised and turn against us. We have to validate everything it touches, coming and going, with that zero-trust mindset.
So as we wrap this up, I want to leave you with one final question to really chew on. Think about the AI systems you're building, or even just the ones you use every day.
Now that you know the risks, now that you see how easily they can be manipulated, you have to ask yourself, is your AI a helpful colleague? Or is it a vulnerability, a confused deputy, just waiting for the right prompt to be exploited?